Let's take a look now at 13. So 13, during a scouting exercise, Ramiro leaves camp and hikes 3 miles on a bearing of 10 degrees. He then hikes 2 miles on a bearing of 110 degrees. Based off this information, approximately how far is Ramiro from his starting position? All right, 6 types of problems. What type is this one? So I got 1 vote for vectors. Does it say the word vector? So how do you know it's a vector? There's a direction and a magnitude. There's actually 2 directions and magnitudes. And so what vectors do, as we've learned throughout the years, vectors all add together. And so this is a vector problem. And before we get started, I want you to know this is one of the lowest scored questions we had. Only 39% of students got this one correct. So it is one we can certainly work on. All right, with vectors, there are 2 things I would highly recommend you write down. When you take this, to have a sheet of paper and to write 2 things down, and then we'll use our calculator to get our final answer. One is an X and Y axis. Highly recommend that. What's the other thing? Can you tell me what's the other thing we should write down? Yeah, what kind of chart? What do I call that thing? I call it a tic-tac-toe. I might call it a T-chart. I might call it a 4x3. Yeah, I heard both T-chart and I heard 4x3. Yeah, let's go ahead and fill this out. Okay, so to label, over here, they did not say X and Y. They did not say anything. They said just angles. Because they did not say north, south, east, west, anything like that, I'm just going to go ahead and put X and Y here. Because they didn't use the words northeast, southwest, I'm just going to leave it as X and Y. They tell us the first one is 0, 10 degrees. Now, whenever they do a 3-digit number like that, that just means you start from a standard position, meaning you start at where a 0 normally is, right here. We start from 0. So let's draw our first vector. I'll do it in blue. First vector, it's 10 degrees. So tell me when you think I've traveled 10 degrees. All right, it's not too far. Let's just go like that. I'm gonna make it a little bit shorter so I can fit in a second. So there's the first vector, and it's 3 miles at 10 degrees. That's 3 miles. Okay, and then what happens on the second vector? 2 miles. So it's 2 miles at 110 degrees. Okay, so here we're starting over. So this is a brand new spot. So how many degrees would it be if I made it like that? 0. So tell me, how many degrees is it to there? That would be 90. And so I need to go about 20 more. Would y'all say that's about 110? Okay, so we're going to say that's 110. Now, just to make sense out of this, I'm going to add a little dash line here from here so I can see where the new 0 would be. If that's also 0 degrees, then the second one, I'm just adding this so we can see it later. This would be 110 degrees. Oh, I see I forgot to label 110. And I forgot to label this one as 10 degrees here. And this would be 2 miles. So that's our drawing, except for I would not get credit right there if I was looking for a picture. What's wrong with that drawing?
There is no displacement that far.
What's the correct word I use? There is no. Starts with an R. Resultant. We need the resultant. That means from the start to the finish. You need to add a resultant here. This one would be our resultant. And I'm gonna, whoops. What I am gonna do is I'm gonna fill it in so I'm not distracted by 2 dashed lines. So I'm gonna cover this up. Yes, ma'am. Okay, so there's our diagram. Our diagram's now finished. Now let's go over the T-chart. Make sure we fill this in correctly. What do I put across the top? X, Y, H, beta. Now on the sides, after we label X, Y, H, and theta, I usually do 1, 2, R. So the first one's blue. Where am I? There we go. 1, 2, and my resultant I drew in black, so I'll do that in black again. All right, let's talk about this first blue vector. Does this appear to you to be a x-axis, a A y-axis or a diagonal h? Diagonal h, I agree. We had the value of being 3 miles. Right there, it was 3 miles, so that is our h. Our h is 3. Let me put this in blue. 3 miles, and the bearing, it's coming from standard position, so it's real easy. All we're gonna do in the calculator is do angle 10 degrees. Angle 10. You could do 0, 10, but 10 is fine. Okay, what about vector 2? When you look at vector 2, does that look like an x-axis to you, a y-axis, or a diagonal h? Again, it's a diagonal h. So we put that the value of 2 as an h, and for the angle, 110 degrees. Notice I use the angle symbol here because that's what the calculator needs to add these up. Now, vectors always do what? What do vectors always do to each other? They add, they subtract, they multiply, they divide. They're going to add. For the sake of pre-calculus ACP, they're going to add. Okay, so that's. Okay, so as we were saying, vectors always add. For the sake of this test, vectors always add. So let's pull up our calculators. First thing, make sure, what mode are we going to stick in? We're just going to stick with radians. Since we're sticking with radians, we need to make sure we type in the degree symbol. So first, where do you find the vector button? Or how do you enter in a vector into the calculator? Control parenthesis. You need to remember that one. Control parentheses. So we do 3 comma. Where's that angle symbol? You can press book if you want a shortcut. If you press control book, it'll go to the 4th page where it's actually at. Press control book, it'll jump straight to that 4th page. So it's the 4th page that looks like that. So control book takes you straight there, and you'll see that angle. It's 3 and then 10 degrees. Don't forget to put the degree symbol. You can find that in with pi. All right, and one more time, what do we say vectors always do? Add. So go outside that vector, hit a plus, control left bracket, and we have 2 comma. I gotta do the angle symbol again. Where do I find that one more time? Control book, angle symbol, 110 degrees, and then one more time, put that degree symbol there. All right, when we press enter, what values do they give us as the answer or the resultant? What values of the resultant do they give you? All right, y'all answered both ways. You said the exact values, 2.27 and 2.4, and then Andrew says what the values actually represent. They represent x and y. This is the x and y of the resultant. The resultant is 2.27 units to the right, and it's 2.4 units high. That's where this point right there would be located. That's what we just solved for. That's 2.27, and this is 2.4. Now, this problem doesn't ask for that. It says approximately how far is Ramiro? Approximately how far? What would that be? Would that be the x value, the y value, or this diagonal resultant? If we want to know how far Ramiro is from camp, it would not be the x value. Would not be the vertical value, the horizontal nor the vertical. It would be the diagonal value. We need to know the magnitude. How do we get the calculator to tell us that? Menu 7 C for vector. So menu 7 says matrix and vectors. C says vectors. Convert to polar. Hit enter. You'll have your answer. Now notice this is in radians. So if you needed a degree angle, we'd have to work on that. But it's 3.3 for the H. And in radians, the angle is 0.8 in radians. So the answer would be B.